All right, this is our second day on ANOVA. You should find in your course pack a handout with the SPSS output for depression. We're going to start with just a practice write-up for that. So I think it should be around page 7.9. And you have the independent variable being different therapies and the dependent variable being amount of self-reported depression. And so we have here 4 different kinds of therapy: control condition, talk, drugs, and then taking a stats class is the last type of therapy. And you have the output here, and I'm showing you how to put it into SPSS and a post hoc. So go ahead and pause the video while you write up the paragraph for this output. Okay, welcome back. You should notice on the F value here that it is significant. And we can see down here, we have the difference being between taking a stats class and the other 3 levels. So this here is going to dictate how our sentences, our middle sentence gets written. Okay, so we'd start off and say the hypothesis was supported. Participants taking a stats class had significantly lower levels, had a significantly lower depression than those receiving drugs, given the mean, talk therapy, or no treatment. And then I summarize the statistic here, comma, p is less than or equal to 0.05. So you'll notice that we compared this one thing to these 3 things and say it's significantly lower. But notice I'm not saying that these other 3 things, the drugs, talk, or no treatment, differed significantly. And then my last sentence, since it was significant, I'm going to talk about the effect size. I say treatment has a large effect on depression, accounting for about 75% of the variance. And then I give the eta squared. Just to remember or refresh your memory, we get the eta squared by taking the sum of squares between groups divided by the sum of squares total. Degrees of freedom correspond to degrees of freedom between groups and within groups in that order. And that's, of course, where we get the F. Oh, and then if you come back, these are where we get the means to talk about. Okay. Little review here on the logic of partitioning. So let's imagine we have a study, does alcohol affect reaction time? So we have no alcohol, 2 beers, and 4 beers. And, let's see here. Okay, so what accounts for variability within groups? So in other words, why do these values differ from one another? Why do these differ, and why do these differ within these groups? That's because of sampling error. So, for example, maybe somebody just has a slightly faster reaction time, and that accounts for the difference between the 10 and 20. Or between here, 15 and 25, maybe it has to do with how much sleep they got the night before. 15 and 30, maybe that's how they understood the instructions or how much they were paying attention. But when we talk for what accounts for variability between groups, then in essence, you're comparing the sample means in the 3 groups and why the sample means might differ. Now, they could differ because of the same reason scores differ within a group, that is because of error, but it could also be treatment effect. So up here, it's just error, and down here, it's treatment plus error, accounting for the difference or the variability. So what's the formula for F? F is equal to mean squares between groups divided by mean squares within groups. Sorry, my pen is not cooperating. Okay, so some more questions here. If the alcohol content of the beers is not held constant, what happens? So in other words, we know that the alcohol is what may be affecting the reaction time, and different beers have different levels of alcohol. Okay. So if the alcohol content is not held constant, that means the air is going to increase. That's A. So we know the extent to which we standardize affects the amount of air that we have. Okay, and then if the alcohol content is not held constant, we're letting more air enter in, that's more noise. So that's going to decrease F. So that would be B down here. Okay, does alcohol affect reaction time? First of all, now we're going to identify the treatment. The treatment is the alcohol, right? And if the alcohol affects reaction time, then there's a treatment effect. And we asked how sampling air might arise, so I already gave some indication of that. It could be, and that's what would cause differences just within groups. That could be just how slow or fast somebody is, right? Different levels of dexterity or coordination. Could be how much sleep they've gotten. It could be how motivated they were to pay attention. All kinds of things could affect reaction time. All right, one important thing to note down here is that we have different sample means that are trying to represent what's going on with the three groups, and ultimately the sample means are trying to represent population means, the no alcohol 2 beers and 4 beers. If you have the sample means based on just a little bit of variability, they're going to be more accurate. But as you have more variability in the groups, within the groups, these sample means become less and less accurate, and they do a worse and worse job of accounting for or representing the mu's. But just remember, the essence of this is you calculate sample means, but you don't really care about whether the sample means differ. You care about whether the population means differ. Okay, so what would our hypothesis testing steps be? We compare the three sample means. The null would be that all the mu's would be equal. The alternative would be not all of the mu's are equal. And then we do our setup. Alpha is equal to 0.05. Degrees of freedom between group is equal to the number of groups minus 1, so that's 2. Degrees of freedom within group, number of participants minus the number of groups. So we got 12 participants total. 4 times 3. 12 minus 3 is 9. With those two numbers, we could look up F critical in the back. Okay, and then if we were doing this on SPSS, we would get output like the following. So the descriptive statistics here showing the different means that we got in the three groups. And you would have down here the source of variation table with an F of 2 point something. And it is not significant because it is not below 0.05. The p-value is not below 0.05. So you shouldn't be surprised that all the means are in the same column, meaning that there's no significant difference between any of these means. Okay, so graphically it would look like this. That might suggest to you that there is an effect here, but in fact, if we look closely at the means with some error bars around them, let me show you. Is it possible that you could draw a line through here? In other words, where all of the groups actually have a mean of 18 point something in terms of reaction time, and that any differences are just due to sampling error? In other words, could it be possible that the mean of this group is here, the mean of this group is here, and the mean of this group is here? Yes. And if the answer is yes, if error around the means could explain the differences we're observing between the means, then we're going to say no dice. We're going to retain the null and not claim a treatment effect. Okay, so last but not least, you would want to write that up. So why don't you pause for a second here and see if you can come up with that, and then I will show you the answer. All right, you should have gotten the hypothesis was not supported. The reaction time following the no alcohol 2 beers and 4 beers did not differ significantly. If you're doing the write-up and you have an effect size to describe, you have two options as far as how I'm teaching you this to describe it. You could either use this first option and just say treatment accounted for about 75% of the variance in depression, and give that. You can also be more specific, say caffeine has a large effect on food finding behavior, and then explain the variance. So basically, both are acceptable. I'm not consistent in how I do them, so either one's fine. Remember, there are these guidelines on how to interpret the sizes. So Cohen suggests that anything between 0.01 and 0.09, so in other words, less than 10%, is medium. If you're above 0.09 to 0.25, it's medium, and anything above 25% is large. Okay, just some more practice and a neat kind of study. So one of the neat things about psychology and how it intersects with philosophy is that psychology understands that the human mind is embodied. In other words, it's wired into our bodies, and what we do with our bodies affects the way the mind works. So in other words, it's not like a computer that's separate from the world and does its internal calculations. A fundamental element of our cognition is that it's embodied. So just if you think about if you're walking down the street and you talk about something in the past, the way we conceptualize the past has to do with how when we pass something physically, it becomes in the past for us. So the fact that we have bodies and our bodies interact with the world in certain ways is part of our perceptual cognitive system. Okay, so you can see this in math. So they do this problem with kids or this research with kids, where they are seeing how important the gesture is towards helping the kids get the correct answer. And they have two types of, the type of problem is like this, where you have 6 and a 3 and a 4. And what they do is they teach the kid to put the two fingers on this number, on these two numbers, and then one finger over here, right? Because the 4 is going to take care of itself. The 4 will balance out. So these two numbers have to combine to make this number. In other words, this number has to be 10. And you can teach a gesture to do that. So here, the kid would point to 9 and 2, put the other finger here, and they would get that 9 and 2 have to become 11. Okay. So let's say we do this in a study, and we have the no gesture condition, a partial correct gesture, and a correct gesture. If I recall right, the partial correct gesture is the kid points at two numbers, but they don't point at the blank where those two numbers add up to a third value. Okay, so it's smart that they have this middle condition. All right, so those three groups, we got an F of 11 something. That means it's significant because, the p-value is telling you it's significant. So we're down here and we see that this is in one column, this is in another column, and this is in another column. So I know the write-up's going to go A is significantly less than B, which in turn is significantly less than C. So that phrase again is which in turn. All right, and I forgot here, I have these pictures of the gesturing. So this is the correct gesture. So you can see how the girl is combining these three things into that thing. That's the correct gesture. And then the no gesture, the kid just has to look at it. There's another potential problem with the no gesture condition in that the kid's hair is really spiky, so he might not be able to see straight. Okay, output. So take a second and try to write up the output for this, the paragraph, and when you're ready, you can continue. Okay, so the write-up, the hypothesis was supported. Participants trained in gestures solved significantly more problems correctly than those trained in partial gestures. And then watch this wonderful pivot, who in turn solved more correctly than those who learned no gestures. So in other words, you are trying to work through this. A is greater than B is greater than C kind of logic. And you say this is greater than this, and then woohoo B, which in turn solve more than the others. So nah, and then nah. And then you summarize the F statistic there. And you need the eta squared, 45%. Problem solving, eta squared, sorry, my symbol messed up there. Eta squared is equal to 0.4513. Just to refresh, remember eta squared is sum of squares between groups divided by sum of squares total. So here we have the outcome. There's 4 different outcomes, but the basic study is the same. So the study, imagine that you're trying to get somebody to remember a set of objects, say, and you can do different things. The 0 elaboration would be you just show them the objects. Lower elaboration might be maybe they look at the objects and they say that the name of the objects out loud. And then medium elaboration might be they group the objects somehow. And then maybe high elaboration is they imagine like their home and imagine those items being placed in different parts of their home and work at trying to really build a detailed memory. Okay, and then you've got the F table and the output here of the post hoc. So I'm going to stop for a second and let you try to write this out yourself and then hit play again and I'll work through it. Okay. Okay, so outcome 1, we'd say the hypothesis was supported. High elaboration produced significantly better recall. So that's this. Then 0, low, or medium elaboration. And then I'd summarize the F would be here. F with 3 and 12 degrees of freedom is equal to 11. It's significant because the P is less than 0.05. So then I got to do my eta squared sentence. Elaboration accounted for a large amount of variance in recall. Meh. Okay, pause it and go ahead and write the outcome for outcome 2 and you can check it. Okay, so outcome 2. The hypothesis was supported. Here we have high elaboration produced significantly better recall than medium, which in turn produced significantly better than both low or 0. So these two are in the same bucket. And then I summarize F. F with 3 and 12 degrees of freedom is equal to 44. It's significant. The effect size sentence, elaboration, my independent variable, accounted for a large amount of variance in recall, my dependent variable, and then I give my eta squared. All right, outcome 3. Go ahead, pause it, work that out, and then you can start it again. All right, outcome 3. The hypothesis was supported. So high elaboration produced significantly better recall than median, which in turn significantly exceeded low, which in turn significantly exceeded 0. You got all these differences. Then I'd summarize F. F with, okay, sorry, got some computer problems here. I got 3 and 12 degrees of freedom. F's equal to 20, significant. Elaboration accounted for a large amount of variance in recall. Eta squared is equal to 0.8333. Okay, and then last but not least, outcome 4. So you can pause it and give it a whirl. Okay, outcome 4. Hypothesis was not supported. All right, F is... wait, sorry, I said that wrong. Take that back. Hypothesis was supported. High elaboration, and this is a little more complicated, right? But high elaboration produced significantly better recall than 0. So that's what's going on. And these do not differ significantly because they appear in both columns, right? So you might say, well, is 5.5 different than 4.5? No, because 4.5 and 5.5 share a column. And you might say, well, is 2.5 different from 4.0? No, because they share a column. So the other ones that don't share a column are 2.5 and 5.5. So you'd say high elaboration produced significantly better recall than 0. Those two means. F, yeah, elaboration accounted for a large amount of variance in recall, and then eta squared. Okay, and then one last one I suggest you try to do on your own. I don't have the answer for this per se, but this will be a good thinking exercise. So imagine that participants were tutored 0, 3, or 6 hours and then tested on course material. And the results show the correct percentage that these three groups got. So explain in writing how an ANOVA would test for the impact of tutoring on exam performance. So in terms of some key concepts you want to integrate here, variability between groups, variability within groups, then talking about where treatment effect and sampling error show up, and be sure to clarify the independent and dependent variable. So if you can explain this, with including all of these, that will suggest you got a pretty good understanding of it. All right, that's it. Hope you enjoyed. One-way ANOVA, ladies and gentlemen.